Welcome, everyone. The webcast is now live. John, please take it away.
Thanks, Allison. Hi, everyone. Welcome to the latest installment of our ongoing editorial webinar series, Coffee Talk. Each hour-long information-packed episode, organized by the hardworking folks at Redmond Magazine, features the observations and insights of independent experts on a wide range of tech industry topics. Many thanks to the underwriting sponsor of this episode, high-performance enterprise networking solutions provider Juniper Networks. Without their support, this series would not be possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of the Converge 360 Group of 1105 Media, and I'll be your moderator. The title of today's talk is AI for the Data Center, Top Use Cases and Strategies. And our lead presenter is scientist, author, and 22-time Microsoft MVP, Brian Posey. But before we get going, I need to do just a bit of housekeeping. This episode is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. We'll make some time during the talk for questions. Please feel free to type your questions into the Q&A box at any time. We'll do our best to get to all of them. Our sponsor has provided some extra resources you won't want to miss. They're available now on your console. And as a small thank you to the first 200 attendees who stick with us to the end, we will be sending you a $5 gift certificate to Starbucks. It's a cup of joe to go with the info. Now I'd like to tell you a bit more about our first presenter. Brian Posey has written thousands of articles and contributed to dozens of books and video training courses on a wide range of IT topics. He previously served as lead network engineer for the U.S. Department of Defense at Fort Knox and head of the Technology and Engineering Group for the Association of Spaceflight Professionals. He also writes the popular Posey Tips and Tricks column for Redmond Magazine, and he's one of our favorite speakers. You guys are in for an awesome session. Take it away, Brian.
Hey, thank you so much, John. And thank you to our sponsors, Juniper, for allowing me to be here today. So today we're going to be talking all about AI and its use cases in the data center. And one of the things that I want to get out of the way right up front is that it can sometimes be tempting to think of AI as being mostly a consumer-grade technology, or worse yet, perhaps even just a fad. And for good reason. The IT industry, perhaps more so than any other, has seen its share of fads over the years. You know, I'll never forget when the so-called big data revolution occurred. I had someone ask me to write about it, and I did. And when they took a look at it, they were completely bewildered because their definition of big data was completely different from mine, which was probably different from everybody else's. And the same thing with when cloud went mainstream maybe 10 or 15 years ago. Practically overnight, we saw all manner of software vendors remarketing their products to make it appear to be cloud-enabled, cloud-ready, cloud-compatible, or what have you. Well, we're kind of seeing the same thing with AI today. AI is everywhere you look, and it's easy to think of AI as being nothing more than a fad, simply because every vendor imaginable is trying to jump on the AI bandwagon to capitalize on the momentum. But even though AI is indeed overhyped in many areas, I mean, I can definitely think of products that have been AI-enabled that really don't have any practical use for AI. The data center is not one of those areas. There are some very legitimate use cases for AI in the data center, and AI can be extremely helpful. So that's what I want to talk about today. So what are some of these potential use cases? Well, I'll get into all of these in more detail as we go along, but I'm talking about things like automated network operations, predictive maintenance, automated management, all the way from setup to troubleshooting, workload resource management, security, incident detection and response, and capacity planning. So one more side note before I really get into this is that as I go along, I'm taking a hypothetical approach to AI. I'm not talking about any one specific vendor or their product. So why is AI good at all of the things that I just mentioned? Well, it really comes down to the way that AI works. And I certainly don't have time today to go into a great big long comprehensive discussion on the inner workings of AI, but I do want to take just a couple of minutes here at the very beginning and give a very high-level overview of the inner workings of AI, because by doing that, I think it's going to make a lot more sense as we go along why AI is so well adapted to the tasks that I'm going to be discussing. So when it comes to AI, and again, I'm approaching this at an extremely high level, there are three main components that you need to be aware of. The first one is something called a skill. And a skill is just what is AI designed to do? For example, let's suppose that you've got an AI that's designed to take a look at a picture of an animal and then tell you what that animal type is. Well, that's an example of a skill. Every skill is based on one or more classifiers. If the AI is designed to do something really simple, you might only have one classifier. If it's designed to do something complicated, you might have a lot of classifiers. But the classifier is the mechanism that makes the decision. So if, for example, you've got an AI that's designed to look at a picture of an animal and tell you what kind of animal it is, one example of a classifier might be something that makes a determination on if a particular animal is a dog or a cat. And then the third component that I want to quickly mention is the model. And the model is what the classifier looks to in order to make its decision. So what does all of this have to do with the data center? Well, the thing about all of this is that AI is all about probabilities and making predictions. Because the classifier that I mentioned is essentially just a mathematical function. So what you do when you train an AI is you come up with a data set where the outcome is known. So if, for example, we're going back to the example a moment ago with an AI that looks at pictures of animals and tells you what type of animal it is, for the training data, you would start out with pictures of animals and have the animal type embedded in the metadata or have it available somewhere else. And so you run all of this through the classifier and through the model, and then the model sees how well it can predict the known result. And refinements are made along the way. So if the model gets it right, great. If the model gets it wrong, then the AI will make adjustments to things like the biases and the weighting, and sometimes even to the mathematical formula itself. Again, there are a lot of different varieties of AI out there. But the idea is that the model is run over and over on this training data, and the mathematical formula and the weights and biases are refined over and over again until that model is as accurate as it possibly can be. Now, once you achieve that level of accuracy, then you no longer have to have a known output. The AI is able to take a look at raw data and tell you what the result is based on the training that it's had. So that's an example of a mature AI. Now, the important takeaway is that AI never truly knows the output. It only knows a probability. So as an example, let's talk about spam filtering. AI has no idea if a message is spam or if it's a legitimate message. So what it does is it takes a look at the various characteristics of an email message, and it comes up with a percentage of likelihood for it to be spam. So AI might look at a message and say, okay, I don't know if this is spam or not, but there's a 90% likelihood that this is spam based on what I know about spam. So that's the way that AI works. And that explanation is going to make a lot more sense with regard to relevance as we go along. So let's put all of this into practice. The important thing to know is that in your data center, more or less every piece of hardware that you've got produces massive amounts of logging data. And in addition to this logging data generated by the hardware, you also have huge amounts of logging data that are generated at the software level. And that holds true whether we're talking about operating systems or middleware or line of business applications or pretty much anything else. Additionally, we have real-time signals that are generated as operations continue throughout the day. So there's huge amounts of information within your data center that AI can capitalize on. AI can be trained against all of that logging data and against the real-time signals. And so in doing so, all of the classifiers learn what's normal for your network. And that also means that AI is able to recognize anything that is abnormal. And incidentally, this is the same model that Las Vegas casinos have used for decades at their gaming tables. If you've ever been to a casino, you'll know that no matter which table you sit down at, no matter who is doing the dealing, card games are always dealt in an extremely consistent way. Every dealer does things exactly like every other dealer. And the casinos learned a long time ago that by dealing games in a very uniform and regimented way, it makes things that are abnormal stand out, thereby making it easier to catch card cheaters. You know, if you've ever seen, whether it be in real life or in a movie, somebody moved their thumb the wrong way in a poker game and all of a sudden security's all over them, it's because those games are dealt in such a uniform way that it makes it possible to catch those subtle movements that normally might go unnoticed. Well, AI works in a very similar way with regard to your data center. AI ingests all of those massive amounts of data that come in, whether it be real-time signals or information embedded in your logs, and it looks for anything that's abnormal, kind of the way that casinos look for abnormalities in a card game. And it's able to take those abnormalities and turn them into actionable insights. Now, the interesting thing about all of this is that the sheer volume of logging data and data from real-time signals makes it almost impossible for a human to go through all of the logs on a daily basis and thoroughly understand what's going on in the network. There's just too much logging data to look at, and even if it were somehow possible for a human to look at all of that, sometimes the signs of an abnormality are extremely subtle, so a human is likely to just glance right over it and not even notice. AI is completely different because, a lot of times we talk about computers being overloaded by data and having too much work to do. Well, AI is kind of the opposite of that because AI absolutely thrives on having huge amounts of data available to it. I mean, think about the training process that I talked about on the previous slide, or I guess it was the slide before that, where AI looks at all of that logging data and learns what's normal for your network. The more training data is available, the better job AI is going to be able to do. So AI thrives on having access to all of that data within your data centers. So even though information overload is a huge problem for humans, AI works best when there's lots and lots of data for it to act on. Now, more importantly, you have to remember that all of that data is coming from a variety of different sources. As I mentioned a moment ago, all of your hardware components are generating logging data. You're generating logging data at the software level. If you've got a hybrid multi-cloud environment, you've got cloud services that are generating logging data. So you've got all of these different sources that are providing logging data to your AI engine. And what that means is that if your AI is able to ingest all of that data, then it's able to get a comprehensive picture of what's going on in your organization across multiple systems. And that's what makes it so good at being able to do things like root cause analytics, because it knows what's going on with, practically speaking, every component in your entire data center at both the hardware and the software level, assuming that it's able to ingest all of that data. And then interestingly, there are tools out there that will even allow the AI to ingest all of that data and allow an admin to perform natural language queries against that data. So an admin might sit down on a console and type something like, is there anything here that I need to be concerned about today? Is there anything that would suggest that maybe there's a malware infection? Questions like that. So why does root cause analytics matter? Well, there's an old cliche, but it's true, that in a data center, downtime is money. And I would even go so far as to say diminished performance costs money. Because in an enterprise environment, anytime a key workload goes offline, there's a huge cost per minute associated with that. And even if the workload doesn't go all the way offline, just the fact that it's operating at below the level that it needs to can oftentimes cost an organization a lot of money. So if AI is able to have a comprehensive picture of your entire IT operations and it's able to spot the problem and tell you how to fix it, well, that's going to go a long way toward preventing downtime and helping you to meet those SLAs. And interestingly, too, it can also help prevent downtime in other ways because, in my experience, human error is one of the leading causes of downtime and network outages. It's easy to dismiss that as it can't possibly be true, but I've been in IT for well over 30 years. I started my career way back in 1992 when I was a teenager. And during that time, I've seen countless examples of human error causing outages. Right here on this slide, these are just a few examples, and I could actually go on and on, but let's just briefly talk about a few of these. First, we have a technician might try to fix and then move on to something else. Let me phrase that again. That didn't come out quite right. A technician might try to fix something, and when that doesn't work, just move on to something else without reversing their previous action. I've also seen technicians try what's sometimes referred to as the shotgun approach, where they don't quite know how to fix it, so they'll try a whole bunch of things all at once and just hope something fixes the problem. Also, failing to document actions during the troubleshooting process. And the reason why that's so important is because if something else breaks later on, you've got to be able to know whether the thing that broke was related to the fix that was put in place or not. And it's hard to be able to make that determination without having documentation of the fix. The third thing on the list, there's sometimes a temptation to skip over simple fixes in favor of more advanced fixes. So, for example, a system's having problems, and rather than looking for a simple configuration error, a technician might decide to reinstall the entire operating system. Also, a technician might modify critical files during the troubleshooting process without first making sure that there's a backup of those files. An IT pro might rush to fix a lab production environment without first attempting a fix in a lab environment. So there's no direct knowledge that that fix is going to work. You don't know for sure. And rather than trying the fix on a lab system, the technician tries it in a production environment first, potentially causing even more problems. Another thing, and I myself am very guilty of this one, is that there's sometimes a temptation to persist with a fix that isn't working rather than rolling back a system and trying something else. Another one I've seen from time to time is over-engineering a solution. So, for example, a system isn't producing the desired output, and rather than fixing the problem the right way, the technician might write a PowerShell script that just converts the output into the format that it's needed in. That's an example of an over-engineered solution, and that's something that does occur in the real world. And then, assuming that the cause of an issue is something that has been experienced in the past rather than fully investigating the issue, and of course, neglecting log files. So let's get back to the subject of AI. One of the things that makes AI so good for use in the data center is that AI can sometimes predict the future. So remember, AI examines all of the data that's available to it, and it looks at that data and tries to understand it, even if that data is something that seems insignificant and is something that a human might ignore. So let's suppose for a moment that you've got a server and it's got a network adapter in it, and that network adapter is having an excessive number of retries. Now, I'm not talking about a huge number of retries, certainly not enough to be a problem, but it's occasionally having to do a retry, slightly more frequently than might be normally expected. And let's suppose that over a period of months, that retry count slowly increases. Way too slow to be noticed by a human, but it increases nonetheless. Even though a human would almost certainly miss that, it's something that AI could pick up on. And because AI detects that, it can also potentially take action on that. So it might generate an alert and tell the administrator, hey, this network card may be going out, and you might want to replace this before it can cause a problem. Another thing that it might do is reroute the traffic to avoid using that network card until it can be replaced. So in other words, AI can identify potential issues before they can become a problem and help you to remediate those issues. So in this regard, think of AI as almost like having a self-healing network. So what about going beyond self-healing? Well, even though AI tools can sometimes detect potential issues and take corrective action, AI may be able to do more than just look for problems. AI can also be good at network optimization or resource optimization. Because, as I mentioned several times already, AI learns what's normal for your network and it looks for abnormalities. So with that in mind, imagine for a moment that you've got a mission-critical workload and the AI detects a huge activity spike on that workload. Well, the first thing that it's probably going to do, depending on the tool that you're using, is to look for an underlying cause. So let's say that it does that and it finds that everything's working exactly like it should be. Nothing nefarious is going on, nothing is broken. You've just got a huge traffic spike. Well, in that type of situation, the AI may be able to take corrective action to more evenly distribute network traffic. It might dynamically scale the application. It might even perform cloud bursting. And all of that can be done by using raw performance metrics so that way the application is getting the resource that it needs in that given moment, and then it can put everything back to normal once the traffic begins to decrease. Another thing that AI is really good at is predictive maintenance. So remember, AI tries to ingest all of the logging data that it possibly can. And sometimes this is really high-level logging data, but sometimes it's really low-level and granular. I'm talking about things like performance metrics on an individual system, the types of things that would be exposed through the Windows Performance Monitor. And this might include things like CPU usage percentages, storage I/O use, the smart status on your disks, network latency, packet loss, and things like that. And all of this can be observed in real time. So given that AI knows what's normal and that it has access to these types of metrics, it can be used for predictive maintenance. So for example, AI might be able to predict the failure of a particular hardware component based on patterns that have evolved over time. It could even go so far as classifying individual components within your systems as being healthy or being at risk or being failing. And in some cases, AI even uses a regression model that predicts the remaining useful life of various components. So for example, solid-state disks wear out over time as write operations occur. You've probably seen tools that will tell you this disk has 84% of its life remaining. Well, AI can use that types of information, not just for disk, but also for other types of components that are serviceable, things like UPS batteries and things like that, and give you a report showing how much life is predicted to be remaining in those components so that you can plan for the replacement when the time comes. So AI may even be able to give you a proactive maintenance schedule based on a combination of hardware health and the manufacturer's recommendations. And there are even tools out there that use smart cameras to look for things that need your attention. For example, a smart camera might detect a frayed cable or dust buildup on an air intake and tell you that you need to address those particular issues. Another thing that exists is workload resource allocation. So the idea being that AI can be used for optimal placement of virtual machines based on the load on various virtualization hosts, the thermal load. In other words, if one host is getting too hot, maybe it would shift some of the workload to another host dynamically. Location, so that you can minimize the latency involved in that application. Cost if you're running that workload in the cloud. There are all sorts of ways that workloads can be optimized. Also, there is cost optimization that can be done by AI. AI might schedule a less critical workload to run during off-peak hours as a way of reducing its cost. AI can also assist with fault tolerance by moving workloads off of a server that's predicted to have a failure and onto a healthy system before a failure can occur. And it can select the best platform for each workload based on factors such as performance, cost, compliance requirements, and workloads can be dynamically moved around as needed as these factors change. Another thing that AI is really good at is capacity planning. Now, capacity planning is one of those things that's been around for years and years. It's probably the first way that I ever saw AI being used in a data center. But one of the things that a lot of people might not necessarily realize is that AI-based capacity planning has kind of grown up over the years. It's matured and it's far more capable than it once was. Because the older style of capacity planning was based on the idea that, okay, you're using certain resources over time. Those resources are consumable. So if we can monitor resource usage, we can extrapolate future needs. So for example, if you're consuming a certain amount of hard disk space every month, then it doesn't take all that much to extrapolate that number and figure out when you're going to run out of disk space. That's the way the old capacity planning tools worked. Newer capacity planning tools that are based on AI tend to look at external factors as well. So for example, maybe your business has seasonal demand spikes or seasonal drops in demand. Maybe you've got a new product launch that's coming, or you've got a special project. Well, all of those types of things are going to impact your IT resource usage. So a modern capacity planning tool not only looks at how many resources are you currently using, it's also going to look at how that resource utilization is likely to change in the near future based on all of these things that I talked about, seasonal demand, upcoming projects, things like that. So as part of the capacity planning process, AI might also consolidate VMs into fewer hosts during off-peak hours, thereby saving power and bringing down your cost. And it might suggest cloud bursting for some workloads. Additionally, AI capacity planning can improve procurement decisions because if you're able to accurately estimate exactly what it is that you need, then you're not going to have to worry about overbuying or underbuying when it comes time to purchase those resources. And interestingly, some of the new capacity planning tools also look at how the capacity planning decisions are going to impact related systems. So for example, if you've got a system running a critical workload and you have to add capacity to that system, well, then a good capacity planning tool is also going to tell you that you need to add capacity to your backups as well. Another way that AI is often used is in security incident detection and response. And this goes back to what I was talking about earlier about AI learns what's normal for your network so that anything abnormal stands out. So as an example, if you've got a user who every Monday, Tuesday, Wednesday, Thursday, and Friday comes into the office, logs onto the workstation at 9 a.m., and opens a particular application, well, that's a pattern. That's something that's very normal for that user, and that's something that AI can look at as being a normal situation. Now, if that same user were to log on in the middle of the night from the rogue country of choice, whatever that may be on the other side of the world, and they tried to access a different application, and they were just in the office 5 hours ago, but now they're on the other side of the world, well, that's an extreme abnormality, and that's something that any good security incident and response system should be able to pick up on and determine that something is amiss. Better still, a system like this can oftentimes take proactive action by running a response based on what's going on. And this might involve things like isolating a compromised device, automatically changing a user's credentials if there's a belief that the account has been compromised, blocking the IP addresses associated with the attack, and things like that. So why does all of this matter? Well, there are any number of reasons, but the important thing is that self-healing AI can find and fix problems without human intervention. So this is going to reduce your mean time to resolution, and it's also going to potentially eliminate human error. Also, AI reduces the need for manual oversight, freeing up IT teams to focus on strategic initiatives. Also, automation can reduce costs through improved resource utilization, less staffing hours spent, and fewer unplanned outages. AI can also help with your purchasing decisions, keeping you from overbuying or underbuying systems as you need to add capacity. Some AI out there is able to automatically configure data center hardware. So let's say that you've gone through the capacity planning process, you've bought a bunch of new data center hardware, you've installed it all in the rack. Well, normally there's a really long, involved configuration process that goes into setting all of that up. In some cases, AI can handle all of that for you. So all of this is to say that AI can deliver an almost immediate return on investment. You invest the money for an AI tool, but it's going to save you money depending on what that tool is in things like reduced troubleshooting, reduced downtime. Sometimes you'll even be able to reduce your power consumption within the data center simply because of the way that AI is able to consolidate certain workloads. So AI can go a long way toward making your data center a lot more reliable, more energy efficient, and reducing your costs and your downtime. And additionally, it can also improve your security depending on what tool you're using. AI can go a really long way towards stopping things like phishing attacks. If there are malicious attachments that are sent in email messages, a lot of the AI tools out there can execute those attachments within a sandboxed environment and just kind of see how they behave and whether or not anything is amiss. There are even tools out there that are based on AI that can reverse engineer things like PowerShell scripts or Python scripts to find out if there's anything malicious that are embedded in them. So all of this is to say that AI can go a really long way toward making your data center a whole lot more efficient, more cutting edge, and just more modern. So with that said, I am just about out of time, but I want to go ahead and take a couple of minutes here at the end for any questions.
Absolutely. Thanks, Brian. I want to let everybody know that there's still time to enter your questions into the Q&A box. We'll do our best to get to all of them. Okay, let's look at this. Our first question here is from Al, who's wondering, what can organizations do to help make sure that IT pros are not relying on AI-enabled tools to the point that their skill sets begin to diminish?
Yeah, that's one of the really big problems that comes along with AI, is that people trust AI a bit too much because AI, no matter how good it is, it can make mistakes. So as an IT pro, you've always got to be in a position where you can say, okay, I think AI got it wrong in this case. We need to do this instead of that. So what can an organization do? The best thing, in my opinion, would be to encourage IT pros to maintain those skill sets. Maybe the organization could require, or at the very least, encourage their IT pros to maintain any certifications that they still have, and just explore, okay, what would you do if you didn't have access to an AI tool, just as a way of keeping those skills sharp.
Okay. Here's one from Perry, who's wondering, can I still use AI-enabled tools if I have some older hardware in my data center that stores logging data in an obscured and unsupported format?
That's a really interesting question. It's going to depend on the tool, but one of the things that AI is really good about in this capacity is figuring out what's really going on. I talked a little bit at the beginning of the presentation about some of the old monitoring tools that would take a look at what's going on in the data center and just generate an alert without really having a lot of intelligence behind it. One of the big problems with those types of tools is that they would produce a lot of noise alerts, things that maybe violated best practices but weren't truly a problem. Or a lot of times there were false alarms. It thought something was going on when it really wasn't. Well, one of the things that makes AI different from the tools that we had back then was that AI has access to information from across your data center. So it's able to correlate data from all kinds of different sources and pull that data together to make sure that what it thinks is going on truly is what's going on. So getting back to that question, if you've got some older equipment in your data center that doesn't support the right type of logging, it may not matter, depending, again, on what your hardware is and what AI tools you're using, because AI can very often correlate data from multiple sources. So even if you've got that one component that doesn't produce any useful logging data, the AI may be able to infer what's going on by looking at other attached resources and seeing how those resources are being affected.
Okay, we've got time for one more question for Brian, and it's coming from Sunny, who's wondering, who says, you talked about human error during the troubleshooting process. In your experience, is human error something that tends to happen with an experienced IT staff, or is it mostly newer IT employees who tend to make the types of mistakes that you talked about?
I would say it's both. Like I said, I've been in IT for over 30 years, and I'm like anybody else. I still make mistakes. Certainly it's easy to see how a newbie could make a mistake, but when it comes to those who are a lot more experienced, sometimes there's a bit of overconfidence that can come in. But even if you put that aside, sometimes you can make a mistake just as a result of being under pressure. Because often the more experienced people tend to be the more senior people on the team, and they're the ones who stand the greatest chance of suffering repercussions if they're not able to fix a particular problem. So because of that additional pressure, they might be a little bit hasty with things, and that may lead to mistakes.
Folks, that's all the time we have for this episode of Coffee Talk. Many thanks to Brian Posey for an insightful presentation, and a special thanks to Juniper Networks for their support of this webcast. We couldn't have done it without them. Keep an eye out for our next episode and for your Starbucks gift card. It should be coming your way in the next few days. Thanks, everyone, and have a great day.